Snowflake is most popular cloud data warehouse database, which is widely used nowadays in the market. So before getting into the Snowflake, let me give you some background about the Snowflake. Okay. So Snowflake is one of the company, which was founded in 2012. It's based out in US. So this publicly launched in 2014 October. 2014 October into the market with AWS Cloud. And this was founded by 3 people who are former employees of, or publicly this came into the market in 2014 with AWS. So later on in 2018, it came with Azure Cloud. And in 2019, so it started working on GCP as well. In the market from 2014, AWS, so in the market 70%. So most of the AWS, the Snowflake runs on AWS Cloud because, so in the cloud market, AWS is on top position, right? So the main advantages of Snowflake, this runs on these 3 clouds, AWS, Azure, GCP. And what is the main benefit of using Snowflake? So when you compare with the other traditional data warehouse databases and Snowflake, so already. So what are the benefits when you are moving to the cloud? And there are some drawbacks as well. So can anyone tell us the difference by using on-premises and cloud? What are the benefits, advantages or disadvantages we have in the market in the existing environment when we are going with the on-prem? So when we deal with petabytes of data, huge volume of data, so what are the things we require when it comes to the infra level? We need to have storage and we need to have OS, network, right? And we need to have multiple resources as well relevant to the technologies. And in on-premises, this is again, too much cost. Even when we don't have any forecast, we don't know for next 5 years, what is the volume of data will be in use. So in such type of scenarios, we need to procure the storage in advance. So for next 5 years data, we have to procure the storage right now. So for that, we have to pay in advance, right? Not only for storage, even, for the servers and OS, for all the software side, everything we have to procure the license and we have to pay in advance. This is one disadvantage. And also we have to pay a lot for the data centers, right? And we have to manage. But when we move to the cloud, right? So just we are taking rent. For example, you are using Gmail, right? So you are just logging in, creating your account and you are using the services. So similarly, just you are paying rent for some other services because somebody is providing the service. You are just paying the rent and you are using it. It's like pay-as-you-go method. So similar way, this Snowflake also works. This is completely runs as pay-as-you-go method. So that is one advantage. This is generic term in process of cloud, but in the Snowflake also, this is same. How you are using Azure, AWS, GCP, same. You are using the services from the Snowflake. You are using just the pay-as-you-go method. This is one advantage. And what are the benefits we have for using the Snowflake? The first thing is cost. The cost is very much reduced. In the data warehouse world, we deal with huge data, right? Petabytes of data. Because this data warehouse concept is the OLAP, online analytical processing. Do you guys anywhere heard OLAP? OLTP or OLAP? Online transactional processing. That means like, the real-time data. Okay, the live data. This is like, the current existing business processing system. Let's take it example as ATM, right? So when you go to the ATM, right? So you will withdraw the money. So it will just calculate whatever the limit you have, and based on that, so whenever you withdraw money, so it will, store all your transactions, right? That is like, ongoing basis. But this OLAP, this is used for analytical purpose. Let's say an example. You are using Amazon, right? So using that Amazon, you are buying something, right? When you buy something, and from the next search onwards, the relevant searches will come into the search list, right? And based on your interest and based on your priority, this all behind in the algorithm, right? So analysis based on the analytical basis that will give you the filters and searches. And in other way, for example, if you take an example of bank, right? So throughout the year, so whatever the transactions they made it, they'll have one audit, right? So every year, March they will do audit. So they will analyze the trends, right? Their market. If you take any company, not only for bank, any company, right? So they will have their business analytics, right? So based on the trend, they will go with the business enhancements, and they will go with the market trends for all the analytics, for the company related analytics that will be stored for this OLAP. So this is mainly used for historical purpose, online analytical processing system. So just forget about this OLTP as of now. Only focus on OLTP because we are dealing with OLAP with our training, because this Snowflake is supporting only for OLAP, online analytical processing system. This is just brief intro, but going forward we will deep dive in each topic. So OLAP. So clear about the OLTP and OLAP, right? And now let's get into the benefits of Snowflake. Why we need to learn Snowflake, and what are the main advantages by learning the Snowflake when compared with other technologies. So what are the competitors in the market for Snowflake? So any idea who are the competitors for Snowflake? We have Redshift. This is AWS product. And for Azure, we have Azure Synapse. And for GCP, we have BigQuery. So these are the 3 data warehouse platforms in the market. These are the competitors for Snowflake. But when we have these technologies, why we need to go with the Snowflake? What are the benefits we have? The first point, Redshift, it runs only on AWS, and Azure Synapse, this runs on only Azure, and for BigQuery, GCP. But when you are going with the Snowflake, this runs on all these 3 clouds, AWS, Azure, and GCP. All these 3 clouds. It will not run on any private cloud, and this will not run on any on-premises as well. This is completely cloud data warehouse database. This is like wrapper technology which runs on only cloud platform, and this is like SaaS service, software as a service. Fine. So this is just brief intro about the Snowflake, and let's get into the in detail of Snowflake, how exactly this works. Snowflake is an analytical data warehouse provided as software as a service. Snowflake provides a data warehouse that is faster, easier to use, and far more flexible than traditional data warehouse offerings. So this is just software as a service. And also when you compare with other technologies, right? So like, we may face some performance issues whenever you run like, huge queries, or when you are loading the data into the, databases. It takes, ages based on the data volume, right? And it requires like, more resources, and we need storage, and we need to have like, good bandwidth for the network, right? So all these hiccups will be there. So when you move on to the Snowflake, almost 90% of the hiccups are gone. So the data is much faster and easier to use, and it is more flexible than traditional data warehouse offerings. And the main advantage is there is no hardware for you to select, install, configure, and manage. Here, since we are using, this is cloud data warehouse database, right? So there is no hardware is required. Everything will be managed by Snowflake itself. And also, see, for other database or any other softwares, you have to download the software and you have to install in your machine. You have to configure in, and you have to, see all the required parameters. Then you have to set everything. Then you have to manage. But here, even there is no software is needed for you to install, configure, and manage. This also will be taken care by Snowflake. This is just like create your credentials and just use it. And whatever the services you are acquiring, just that is pay as you go method. That's all. And there is, ongoing maintenance, management, and tuning. Everything is handled by Snowflake. For example, just take any other database technology like Oracle or MS SQL, right? So for that, every quarter they will release some patches, some bug fixes, right? And some new version released. Whenever any new version released, and we have to upgrade our databases, right? Like, there are a lot of maintenance activities involved. Or if you go to the like, the on-premises environment, for example, your database is running on Linux platform and under some EMC storage, right? Some issue with the storage level, some fix should be applied at the storage level. So what will happen? Again, you have to, bring down your services. You have to get the required approval from multiple teams, right? And you need to get the downtime, and for that, for that maintenance activity, we need to bring down our systems. I mean, not only for at the storage level, if any issues with the OS side, if something happens at the storage level, or if you want to apply any bug fixes or patches for the database level, right? You need to bring down the system. So all these kind of maintenance services are there in the regular traditional environments. But here in the Snowflake, all the maintenance activities, everything will be handled by Snowflake, and the Snowflake is giving 99.99% of availability. And also the Snowflake runs completely on cloud infrastructure. Remember this, there is no on-premises system in the Snowflake. And Snowflake manages all aspects of software installations and updates. Whenever any new update or any new version get released, automatically that will be updated by Snowflake in the backend. You don't even know, when that got updated, right? So we'll see, like how frequently, the versions are getting released, and, how frequently the patches, something like, they will apply. Even we never know. In the backend, they will apply on weekly basis or whenever any new patch or new version released. So automatically, whatever the account you are using, automatically it gets updated in the backend. There is no manual intervention is needed from your side. That is the big advantage. And also, Snowflake cannot be run on private cloud infrastructure. It cannot be run on private cloud infrastructure. It's like, the on-premises are hosted. It will not support and it will not run. This only runs on 3 clouds, as I said, AWS, Azure, and GCP. based on the client requirement or client preference, we need to create our Snowflake logins on the specific cloud platform. So we'll see that, okay, how to create that account, everything we will see. And Snowflake is not a packaged software offering that can be installed by a user. Snowflake manages all aspects of software installations and updates. You don't need to download anything from the website, and you don't need to unzip, you don't need to install nothing. So everything, what you have to do is just create your account. That's all. So when it comes to the architecture, how difference between traditional architectures and also Snowflake architecture. So when you observe this PPT here in the left hand side pane, traditional architectures, this is like shared disk, shared storage, single cluster architecture, and also shared nothing, decentralized, local storage, single cluster architecture. That means, for example, if any single point of failure at the disk level, then your entire cluster will be gone. And here also, if anything happens at the local storage level, then your cluster will be in trouble, right? In the traditional architectures. But in Snowflake architecture, this is like combination of both multi-cluster shared data architecture. Here, it's like centralized scale out storage, multiple independent component clusters. Here, the architecture designed such a way that there is no dependency on each layer. If something goes wrong at the storage level, there will be no impact on the query processing layer and also cloud compute layer. It's like, decoupled architecture here we have. That is the beauty of Snowflake architecture. So this is like, the independent compute clusters we have in the Snowflake architecture. So that's the reason here maximum, right? Maximum, the maintenance activities got reduced 90%. Even if we have any few, even those also will be handled or taken care by Snowflake. Snowflake architecture. So Snowflake architecture is a hybrid of traditional shared disk database architectures and also shared nothing database architecture. It's combination of both. Similar to shared disk architectures, Snowflake uses central data repository for persisted data that is accessible from all compute nodes. So here the compute nodes are nothing but the virtual warehouses. We will discuss, going forward, you will come to know like what are these compute resources and compute warehouses in the architecture we are going to discuss. As of now, just remember this terminology, all compute nodes in the data warehouse. So similar to shared nothing architecture, Snowflake process queries using MPP. MPP is nothing but massively parallel processing. That means that will distribute the load among the resources, which will make the performance much faster. Okay. And these compute clusters where each node in the cluster source stores a portion of an entire data set locally. So whenever you are accessing the data from the storage level, right? So that will bring up to the compute cluster, and each node in the cluster, it will store a portion of entire data set locally. This is for shared nothing architecture. And this approach offers the data management simplicity of shared disk architecture, but with performance wise and scale out benefits of the shared nothing architecture. And here, the main, again, the advantage is whenever we required, we can scale up and scale down our resources in both in virtual warehouse and also at the storage level. We'll see that. Snowflake unique architecture consists of 3 layers. What are the 3 layers we have? Database storage layer, query processing layer, and also cloud service layer. This is the multi-clustered shared data architecture. So if you see the starting one, storage resource. Here, this is storage layer. And on top of this, we have compute resources. This is used for query processing. So whenever you fire any queries or when you execute queries, so this layer comes into picture. So here the query processing, all the query processing will be done at the compute resource layer. Here we have virtual warehouses. So we'll discuss about these virtual warehouses. This is like, the new terminology. This is like, the compute node. And on top of this, we have cloud service layer. This cloud service layer, combination of multiple components like authentication and access control, infrastructure manager, optimizer, transaction manager, security, and metadata. So this will coordinate with rest of the two layers, and this will, like administrate all the activities when the query got from end user until query dispatcher. This will taken care all the activities. This is like, complete end-to-end administration activities will be taken care by cloud service layer. We'll see one by one, just overview. Snowflake database storage. Snowflake data loaded, stored, reorganized the data into its internal optimized, compressed columnar format. So when you ask why the performance is much faster in Snowflake, even see, whenever the data gets stored at the storage level, while storing itself internally, the data is optimized. Optimized is nothing but, the data will be stored at the storage level and which will give better performance. So the data itself, while storing, it will be optimized automatically. You no need to optimize, and you no need to tune. But while storing itself, the data will be optimized and also compressed. By default, while storing the data, it will be compressed automatically. And also columnar format. The data will be stored in columnar format. If you take that other traditional databases, the data will be stored in row level format. But when the data stored in columnar format, that will give better performance than row level format fashion. And Snowflake stores this optimized data in the cloud storage. In the backend, obviously, the data will be stored in the cloud storage. So whatever the cloud provider you are using, so it will be stored in the cloud storage. For example, if you are using AWS, the data will be stored in the S3 bucket in the backend. You no need to worry about all the cloud services because that will be taken care by Snowflake. Only you have to know is, yes, the data will be stored in the cloud storage because this is just like wrapper technology which runs only on cloud platforms. And the data objects stored by Snowflakes are not directly visible nor accessible by customers. It's not like, somewhere you stored data, just when you click on the folder, you could see all the files. No, it's not like that. So the data objects stored by Snowflake are not directly visible nor accessible by customers. They are only accessible through SQL query operations run using Snowflake. Only using SQL queries, we need to fetch the data. This is at the storage level. Then query processing layer. Snowflake processes queries using virtual warehouses. Virtual warehouse is nothing but this is at the query processing layer. This is just like RAM. Assume like RAM. If you have good RAM, then your system will have better performance. Similarly, the Snowflake process queries using virtual warehouses. Each virtual warehouse is an MPP compute cluster composed of multiple compute nodes allocated by Snowflake from the cloud provider. From the backend, so that will be allocated for the compute nodes, but you don't see like, for example, if you are using AWS, the EC2 instances will be in place in the backend. So that will be used. But here you have to consider only virtual warehouses. In the backend, what exactly it's using, that's not our job. But what we have to know is when it's running on the cloud provider, yes. So that will be used from the cloud provider and the compute nodes will be allocated by Snowflake from a cloud provider. And again here, this virtual warehouses also, we have t-shirt size of warehouses, how to scale up, how to scale down. Can you go on mute if you're not speaking? Yeah, thank you. So here we can scale up and scale out the resources as well for this virtual warehouses based on the load. Whenever there is huge load, we can increase the warehouse size. Whenever there is no load, you can reduce the warehouse size. So that is the beauty of this query processing layer for the virtual warehouses. And the top layer, cloud service layer. The cloud service layer is collection of services that coordinate activities across Snowflake. These services tie together of all different components of Snowflake in order to process user requests from login to query dispatch. So whatever the components we have in the cloud service layer, that will taken care all the user requests from login to query dispatch. This cloud service layer also runs on compute instances provisioned by Snowflake from the cloud provider. So here we have, these are the services: authentication, infrastructure management, metadata management, query parsing and optimization. This is used for query tuning, and also access control, which will taken care of the access part. So these are all services will be in place and which will administrate from the user request from login to query dispatch. So these are all three layers, very simple. The architecture, when you compare with any of the other technology architecture, this is quite simple and very crystal clear. Only three layers, and each layer is an independent and decoupled architecture. If something goes wrong at the storage level, no impact to the other layers. So same, if something happens at the virtual warehouse, no impact to the other two layers. So this is completely like decoupled environment. There is no dependency on each layer. Each layer, acts as independent layer. That is the beauty or advantages of Snowflake architecture. So as of now, I'm stopping here, and I would be covering some other general topics when it comes to the roles, what are the roles we have, and syllabus, and also certifications. So I'm going to discuss about that. So here, when it comes to the Snowflake technology, so this is used as, so currently in the market as data warehouse, database. One platform, we can use this Snowflake as data warehouse database. We can use this Snowflake as data lake, and also we can use this as ETL or ELT system. And we can use this as data analytics purpose, data application. And also if you want to share some data from one environment to other, you can share the data using data sharing option. So this can be shared in the secured manner. So one solution for multiple problems. And like, in current environment, so whenever, we think about the cloud, we worry about the security, right? Because our data into the some other cloud. But here in the Snowflake, you no need to worry about all the security related issues, because it supports all the security standards, even for PHI data, PII data, right? For example, like, the banking related data. So healthcare, in healthcare domain, we have PHI data, right? So this supports all the security related standards and also certified by specific companies. So even for security wise also, the Snowflake is assuring that it is like, 100% reliable. And this is like, whenever we store the data, that is secured and it supports all the security related standards. These are the three roles we have in the market. And as a part of training, we are covering these three. And based on your interest, like, if you are good in coding, you can move to the data engineer side. Or if you, right from the beginning, if you are into DBA, or if you want to, like, go as a DBA, you can go as a DBA as well, who are like, much experience, like, about 10 years. So, for them market, they'll, the companies will expect that architect role. So we can go as an architect as well. And what are the certifications we have in the Snowflake as of now? So we have SnowPro Core. This is the prerequisite basic certification for the Snowflake. So once you complete this training, if you are interested, just you can clear this Snowflake core certification. This is the basic prerequisite certification. Then after that, once you clear, we have another certifications like Snowpro, Advanced Architect, and also Snowpro Advanced DBA. Earlier we had only two, Snowpro Core and Advanced Architect. But now in the market, we have Architect, DBA, and Data Engineer. And we have Data Scientist, Snowpro Advanced Data Scientist. And the other one is Data Analyst. So these are the certifications we have in the market, which are provided by Snowflake. So Architect, DBA, Data Engineer, Data Scientist, and also Data Analyst. But to clear all these certifications, the basic prerequisite is you have to clear Snowpro Core certification. If you don't clear the Snowpro Core, then you are not eligible to take the other certifications. This is for certification part. And coming to the Snowflake training, so these are the topics we are covering. DBA, I have segregated list of topics, like we are covering end to end all the Snowflake related topics, and I have segregated based on the role. And while explaining, I'll say, so the particular topic is related to DBA or data engineer. So these are the list of topics for DBA, and for developer, these are the topics for developer and architect. So we are going to discuss some real-time scenarios. We will discuss the design flows and also data flows. I'll give you sample, the data design flows for the Snowflake projects. And we are going to cover one data migration project that is like, completely theoretical. So the practical, once you are done all these topics, then you will be able to migrate the data from one environment to another. So for the end-to-end data migration, we are going to cover theoretically, and the other topics. So one day for Python. So we will discuss about the basic Python and also how to connect the Snowflake using Python. We will discuss about some basic syntaxes modules, and AWS. We are covering some additional topics for AWS S3 bucket and also, IAM roles. So like whatever the things are required for the data engineer role or for the Snowflake. So we are going to cover that, and some cloud basics for the PL SQL JavaScript that is used for Snowflake stored procedures, and few data warehouse concepts. So this is all about the Snowflake training curriculum. So we are going to cover all these topics.